In this video, I'll find the area in between two curves. Let's take a look at this. Now you see two curves in front of you here. One is the green curve, and one is the blue curve. The green curve has a function f at x equals to x squared plus 1. The blue curve has a function g at x equals to negative x squared plus 3. Now, we're to find the area of the shaded region in yellow. How do we do that? As you can see, this is not a regular shape like square, rectangle, triangle, trapezoid, or parallelogram. It's an irregular shape. So how do we calculate area of an irregular shape like this? We have to use integral calculus. And how do we use integral calculus to get this area here? Now, let's take a look at this. Let me draw a Cartesian plan here, just like the one above. So that's the first function here. Let's say here. This is f at x equals to x squared plus 1. So it's the first function here. So let's pick a value here. Okay, so this point here, here, and this point here. Let's call this point here negative x, and this point here is x, okay? That's the x value here. If I integrate here, if I integrate f at x dx, and using the lower limit and upper limit here, negative x and x, right? I will evaluate at x and negative x. What am I getting? I'm getting the area of this region here. It's whatever that's above the x-axis until the function. Okay, I'm getting the area of this region here. Okay, let's look at the second scenario. A Cartesian plan like the above, but this time it's this function here. So that is g at x equals to negative x squared plus 3. Just like the second function here. Okay, let me pick a value here. Let's say here or here, right? So I will pick a value here. Okay, so this is negative x, and this one here is x. So if I integrate g at x, this function here, dx, using the lower limit and upper limit, negative x and x. So what am I getting here? It's the area of this region here. Is whatever that's above the x-axis until the function. Okay, if that's the case, if I want the area of the yellow shaded region, what can I do? I have to find the area from here. So from here, how can I draw this? Okay, so it will be from here and here. All this region, subtract the area here. Subtract this area here, which is under the function x squared plus 1. Okay, so let's see how we can do this. Okay, first of all, I don't know what the lower limit and upper limit is. It's not given in the question. So how can we find this lower limit and upper limit? So we have to find the intersection of these two curves. And how can we do this? I have to let this function equals to this function and then find out what the x values could be. There should be two x value here. So I will let f at x equals to g at x. So find the intersections of the curves. So I will have to let f at x equals to g at x. And what is f at x? X squared plus 1. So x squared plus 1 is equal to what's g at x? Negative x squared plus 3. So negative x squared plus 3. Okay, so just move around. So move the negative x squared to this side. I will have x squared plus 1 still here. And move the 3 to this side will be minus 3. Minus 3. On this side will be 0 because I have moved everything to the left side. So what do I have here? X squared plus x squared is 2x squared. Now, plus 1 minus 3 is minus 2, equal to 0. Okay, so factor out the 2. So we have 2x squared minus 1 equal to 0. Divide both sides by 2. x squared minus 1 equal to 0. Then from here, right, add 1 to both sides, x squared is equal to 1. Take the square root of both sides, positive and negative, right? So square root, positive, negative, then 1. So x is equal to positive or negative 1. So we have two x values. So x is equal to negative 1 or x is equal to 1. So what we can see is that both negative 1 and 1 works. So that means the lower limit from here, this one here, is equal to negative 1. And from this point, upper limit here must be 1 for the x value. So now we know the lower limit and the upper limit. So we can do a definite integral to calculate the area of the yellow shaded region. Okay, so first of all, let's do this. Let me write this. So it must be the area under this curve, subtract the area under this curve. So it's the area from here under the blue curve, subtract the area under the green curve to give you the area of the yellow shaded region here. Okay, so I will have to say, so the area of the shaded region we're looking for is the integral, right, from negative 1 to 1 g at x dx minus integral negative 1 to 1 f at x dx. So that's the area we're looking for. Okay, so let's do it one by one. Let's integrate g at x first and evaluate at 1 from negative 1 to 1. Okay, so g at x is negative x squared plus 3. So let's do one by one. Do one first. Okay, so integral negative 1 g at x dx is equal to integral negative 1 to 1 negative x squared plus 3 dx, because this is the g at x function here. Okay, so it's an easy integral. So let's do this, right? Add 1 to the power divided by the new power. So that is, let's say, negative x cubed add 1 to the power divided by the new power, right? Now, a constant, so we just have to add x to the back of the constant, and we're done. Evaluate a from negative 1 to 1. So let's put it in. So that is equal to, put 1 here, negative 1 cubed over 3 plus 3 times 1. Okay, this minus, now put negative 1 into here. So negative 1 cubed over 3 plus 3 times negative 1 here, negative 1. Okay, so let's do this. 1 cubed, negative 1. Okay, so that would be negative 1 over 3 plus 3 minus, now, negative 1 cubed is negative 1, negative is positive. So 1 over 3. Now, negative 1 times 3 is negative 3. Okay. Let's take out the bracket, right? Minus, then minus will become a plus. So what do we have? So overall we have 6 minus 2 over 3. And what is this? We can see that 6 is 18 over 3. Let's find the common denominator. Minus 2 over 3. And that is 16 over 3. Okay, so this is the area under the blue curve. So basically it's this region here. That's the area. 16 over 3. Now let's find the area under the green curve here. And just subtract it from 16 over 3. And we will get the area of the shaded region in yellow. So now we're going to integrate a function f at x, which is x squared plus 1. Let's do it here. Integral from negative 1 to 1 f at x dx. And that is equal to integral from negative 1 to 1 x squared plus 1. Dx. It's an easy integral, so let's do this. Okay, here. Add 1 to the power divided by the power, add 1 to the power divided by the new power, plus, okay, well, integrating 1 is just x. Evaluate a from 0, from -1 to 1. Okay, so let's put 1 into here. So that is equal to, now 1 cube over 3 plus put 1 into here, 1 minus, now put -1 into here. So -1 cube over 3 plus x, and put -1 into x plus -1. Okay, let's group this together. 1 cube over 3 is 1 over 3 plus, now this is 1 minus, okay, let me still keep the bracket for now. Okay, -1 cube is still -1. So -1 over 3 minus 1 minus 1. Okay, now I will take away the bracket. 1 over 3 plus 1 minus, now the sign will flip. Minus minus is plus 1 over 3, and the minus 1 is plus 1. Minus 1 is plus 1. Okay, so I have here is 2 plus 1 is 2 plus 2 over 3. Okay, let's find a common denominator of 2, which is now 6 over 3 plus 2 over 3. That is 8 over 3. Okay, so now we found that the area under the green curve here is 8 over 3. Okay, so we know the area under the blue curve from -1 to 1 is 16 over 3. And the area under the green curve from -1 to 1 is 8 over 3. Then we just need to subtract it to get the area of the shaded region in yellow that we want. 16 over 3 minus 8 over 3. And what is that equal to? 16 minus 8 is 8. 8 over 3. That is the area of the yellow shaded region here. Hope you enjoyed this video. Don't forget to subscribe to my channel. Thank you.